Please subscribe our channel Education Point and press bell icon to get notification of new educational videos.
Hello everyone, you are all welcome to lecture number 156, and here I am discussing the multi-step conversions of aromatic compounds, and these conversions are very important because out of aromatic compounds or derivatives we are going to get variety of organic or aromatic compounds which are having lot of importance and uses in our daily life. So I am discussing one by one. That is aromatic conversions involving multi-steps part 2. These multi-steps aromatic conversions are very helpful in converting lot of aromatic compounds into variety of products, like phenol is converted into benzoic acid into phenol, and iodoform into toluene. So the first conversion is, that is the conversion of phenol into benzoic acid, and there are 4 steps involved. I have given all the reagents and reaction condition. First, that is called Bucherer reaction. It is a name reaction when it is treated with ammonium sulfate and ammonia. And then second step is, that is dihydration will take place, and then with Caesium this diazonium group will be removed by substituted by Cn, and then finally with acid hydrolysis you will get benzoic acid. So here phenol is treated with NH4 twice SO3 NH3, it is changed into aniline, and then it is treated with NaNO2HCl at temperature 278 Kelvin. It is converted into diazonium salt, and then it is treated with Caesium. You will get cyano product where cyanide group is substituted in place of diazonium group, and then it is subjected to acid hydrolysis. In presence of acid hydrolysis, it is converted into benzoic acid. Number second conversion, that is the conversion of benzoic acid into phenol, vice versa. Here the following steps are involved. There are 4 steps. In first step, carboxyl group is removed. It is known as decarboxylation. Then second is sulfonation. Third one, fusion with alkali. And the last step, that is acid hydrolysis. So here benzoic acid is subjected to decarboxylation in presence of sodium, calcium oxide and sodium hydroxide. The COH group will be removed and you will get benzene. Then benzene is treated with concentrated sulfuric acid. You will get sulfur product, that is known as benzene sulfonic acid, and then it is treated with sodium and sodium hydroxide. You will get that is sodium phenoxide, and that sodium phenoxide in many books it is referred as phenolate. So the phenolate and sodium phenoxide is the same thing, and then it is subjected to acid hydrolysis, and finally we get phenol. Number 3 conversion, it is the conversion of iodoform into toluene. How iodoform is converted into toluene? There are 3 steps involved, and the first step is, that is heating with silver, and it will give you acetylene, and then that acetylene is passed through red hot copper, and when acetylene is passed through red hot copper, it is a very common reaction, then cyclization will take place, and that acetylene will be cyclized into aromatic benzene ring. So that cyclization is there, and that reduction in presence of copper tube, and that cyclization is followed by reduction, and then you will get benzene, and then benzene is subjected to Friedel-Crafts reaction, that is called alkylation. In presence of alkyl halide and aluminum trichloride, you will get toluene. So here the number 4 conversion is, that is conversion of formaldehyde into benzylamine, and this conversion involves 3 steps. And first step is, it is treated with Grignard reagent, that is RMGX. Then second one, it is reaction with iodine in presence of phosphorus, and third one is reaction with alcoholic AgNO2. And then fourth one is, that is reduction with SnHCl. So this formaldehyde, when it is treated with Grignard reagent, it will be converted into benzyl alcohol, because hydroxy group is attached to side chain carbon. That's why it is alcohol. And then it is treated with iodine. It is converted into iodo-derivative, that is known as benzyl iodide. And this benzyl iodide is treated with alcoholic AgNO2. It is converted into phenylene nitromethane, because this nitro group is attached to methyl group CH2. That's why it is called phenyl. This is your benzene ring, is called phenyl. And if on side chain anything is attached, it will be given by that name. So there will be no more benzene other. It will be known as phenyl. So it is your phenyl nitro group is attached to methane. So phenyl nitromethane. And then it is treated with SnHCl. You will get benzylamine, because amino group is attached to side chain carbon. That's why it is called benzylamine. Number 5, that is conversion of chloroform into N-methyl aniline. So in this conversion, how to convert N-methyl aniline? There are 2 steps, and first step, it is treated with KOH in presence of aniline. So this reaction is important reaction when you are treating chloroform with aniline in presence of potassium hydroxide. It is called carbylamine reaction. It is called carbylamine reaction, and with this carbylamine reaction, it is converted into phenyl isocyanide, and then it is treated with zinc mercury HCl, and in that acidic medium, it is converted into N-methyl, because methyl group is attached to nitrogen, so it is N-methyl aniline, and this is your aniline. So with this I will stop, and in next lecture again I will be giving you some mixed type of conversions where lot of medicinal compounds are there, and aliphatic, aromatic, so many mixed products are there. With this I will stop today. Thank you very much for watching.